Hi everyone, in this video we're going to work through some examples of using the log properties. So here our goal is to find the exact value of each statement, and all of these are set up so that you should be able to get to an answer that does not contain any logs. So you should be able to get to the point where you can actually take the log of whatever it is that's left. Okay, so first one, and let's see if we remember our properties. We have a property that says, here, I'll write them up at the top, the log base b of u times w is equal to the log base b of u plus the log base b of w. So that's property number one. Property number two says if you have the log of a quotient, it's the difference between logs, W. Property number three, so this is 1, 2, 3, says that the log of something with a power is equal to the power multiplied by the log base b of u. And then we do have our change of base formula, which says if you want to turn the log base b into any other log, you just go ahead and do it, turn it into a log base c of u, but then you have to divide by the new log base c of the old base b. And you want to be really clear here that this is log of, this is function notation, so you can't cancel the logs. They're not attached by multiplication, so division won't get rid of them. So be careful when you're looking at these that you think about how they're hooked on. Okay, so if we have the log base 6 of 9 plus the log base 6 of 4, neither of those looks particularly easy to evaluate. I don't know a power of 6 that will get me 9, and I don't know a power of 6 that will get me 4. But I can apply a log property. Property number 1 says that if you're adding two logs with the same base, you can combine that into a single log. So our base is 6, it will stay a log base 6, but now it will be the log base 6 of 9 times 4, so log base 6 of 36. And that I absolutely can do. What power of 6 gives 36? The answer is 2. Okay, so again, remember with these properties, they work both directions, and actually I would say a lot of the time we end up using it this way to combine two logs into a single log. But we want to be able to go both directions, so you'll have homework practice on both directions. All right, part B, the log base 8 of 16 minus 2 times the log base 8 of 2. So this one is actually kind of interesting because I could find the log base 8 of 2, 8 to the 1/3 gives me 2, and this one's a little trickier, the log base 8 of 16, but that is actually doable as well. I could get down to 2, and then 2 to the 4th is 16, but I want to use the log properties just for the practice, so that is an option. If anybody spotted that and was thinking that, you're not wrong. If you want to use your properties here, though, you have to be a little careful. I hope we're spotting that this looks like property number 2, where I have a subtraction. So I should once again be able to combine it into one log, but you have to take these rules very literally. There is nothing in property 2 that says it's okay for there to be a 2 in front of the log, which means it is not okay for there to be a 2 in front of the log. Lucky for us, property number 3 tells us how to get the 2 moved from out in front of the log inside the log. So we will use property number 3 to move this up into the power. And again, I think the one thing to be really careful about, people are pretty good with that one, I'm going to throw in the parentheses to be really clear here, is that what happens is, oops, it's not an equal to, sorry, that's a minus still, log base 8 of 2 squared. You don't square the entire log, you're only squaring the 2. So if you have a number out in front, you can move it up into the power and it applies only to the input. If you have a number implied only to the input, it has to be the entire input, then you can move it out in front. Okay, so I'm writing extra steps. Probably you could do that 2 squared in your head, but I wanted to make sure you saw it. So we have the log base 8 of 4. And now we can use property number 2. Property number 2 says if you're subtracting two logs with the same base, you can combine them into the single log of the quotient. So not to be confused with change of base where it turns it into the quotient of two logs. This is a single log with a quotient inside. 16 over 4 is just 4. And it looks like we ended up having to do some tricky log work anyway, so I don't know if this saved us a ton of work, but I still think it was good practice to play around with the properties and see if we got to something nice. So I do end up with one of these, what power of 8 gives me 4? These tricky sort of questions. So I would say to answer that question, I can get 8 down to 2 by taking the cube root, and I think that's a good idea because it's easy to get from 2 to 4. It's not so easy to get from 8 to 4. So the cube root of 8 is 2. If my goal is to get to 4, I need to square the 2, which means I'm squaring the cube root of 8. So if I take 8 and cube root it to get 2 and then square it to get 4, I've raised 8 to the 2/3 power, and that is my answer. For part C, I actually know a couple of ways to get through part C. I have a log base 6 of 4 times a log base 2 of 6. So one thing to notice is that they do have different bases, and the change of base formula can help with that. Another possibility, and I think I'll show you both because I think both are kind of cool, we only have one property that tells us anything about multiplying a log by something. So property number 1 tells us about having the log of a product, but we're not multiplying the log by something. Property number 3 has a log multiplied by something. And there is no rule that says this p has to be a nice number like 2 or 3 or 4. So another option is to look at this as our p in property number 3 and move it up into the power. So since I have it labeled, I'm going to go ahead and do that one first, but I will show you change of base as well. Okay, so again, property number 3 says if there's anything multiplied by your log, you can move it up inside the log and make it the power of the input. So I'm going to move this whole thing up and make it the power of 6. So be really clear on where parentheses fall here. That means I have a 6 to the log base 6 of 4 in the parentheses. And this is actually a good thing. Separate off so we don't get mixed up. 6 to the log base 6 of 4, that's inverse operations. They should cancel each other out. If I find the power of 6 that gives me 4 and then I apply that power to 6, I better just get 4. So the 6 and the log base 6 wipe each other out. I get the log base 2 of 4. And then I'm asking myself what power of 2 gives me 4, and the answer is 2. So there it is with property 3. You certainly don't have to do this both ways, but a lot of people spot the change of base instead, so I want to make sure you see that as well. So alternative. We could say, let's change both of these to the same base. So I'll go ahead and mess with that first one again. Let's go ahead and change the first one into a log base 2. So change of base. I'm going to go ahead and say I don't want it to be log base 6 of 4. I want it to be log base 2 of 4. That's way better. But I have to correct for the fact that I made the change. So I now have to divide by the new log, log base 2 of the old base, which was 6. That's not so nice. But what is nice is that I'm then multiplying by a log base 2 of 6. So if you want, you can put that over 1. So again, you want to be really clear that the log base 2 and the 4 are not attached by multiplication. Their function, this is a function, so it's a log of 4. The inverse operation that would get rid of a log base 2 is an exponential with base 2. So we can't cancel the log base 2's out of this fraction because canceling means you're dividing them out and they're not attached by multiplication. But here, I do have things that are attached by multiplication, and the entire log base 2 of 6 shows up in the top and the bottom. So division does undo the multiplication here, and I end up with just the log base 2 of 4, which again is 2. This should work out if you instead decided to change the log base 2 of 6 to a log base 6. So that should be fine as well. Sometimes one way is slightly easier than the other, but both should work. So change of base would work either direction. Okay. D. I see a 3 to the log base 3 of 5 minus log base 3 of 4, and I am very tempted to say 3 to the log base 3. Those are inverse operations and they cancel. But the deal is that only works if they're happening one right after the other in order of operations. So the order here is I have to plug in the 4 and the 5. I have to take the log of each of those. I then subtract, and then I finally raise 3 to that power. So order is subtract and then exponentiate, which means the log base 3 isn't actually sitting right next to the 3 to the power the way it might appear. So if we are going to try to cancel out that 3 and log base 3 to say they're inverses, we have to somehow get rid of the subtraction, which means this is a property number 2 problem again. So we're going to say that the log of a difference, let me say this correctly. The difference between two logs is equal to the log of a quotient. Okay, so the difference between two logs becomes a single log of a quotient. Now, if we look at order of operations, we would take 5 and divide it by 4. We would then take the log of that. We would then raise 3 to that power. These two are now right next to each other, order of operations, so that they will cancel out. And I'm just going to get 5/4, and that's my answer. So it is true that 3 and log base 3 are inverses, and if you're raising 3 to a log base 3, they'll cancel, but you have to be very careful about that order of operations. If there's any other operation, so basically putting this in the exponent is like putting a grouping symbol around it. You have to work in the parentheses first. Okay, so last one is actually kind of similar. I see an e and a natural log, and I want to say those just cancel, but I have to be careful because the order here is take the natural log of 9, then divide by 2, then raise e to that power. So I don't have the natural log and the e happening one right after the other, so they won't cancel. This one, just because of the way it's written, I think really messes with people. So my advice would be to remember that dividing something by 2 is exactly the same as multiplying it by 1/2. I still can't cancel the e and the natural log because that multiplication is in the way, but I do have tricks for rewriting something times a log. So this ends up being a property number 3 thing. It becomes the natural log of 9 to the 1/2 power. And I can go ahead, it doesn't matter which order here. I can find 9 to the 1/2 power, or I can say the e and the natural log now cancel each other out. So I'm going to go ahead and do the 9 to the 1/2 power first. That's the square root of 9, which is 3. And then e to the natural log of 3 better just be 3. I'm asking what power of e gives me 3, and then I'm applying that power to e, so I better get 3. All right, thanks for watching.